Hello. In this lesson, we're going to talk about the Pythagorean Theorem. So our essential question for today is, how can we use the Pythagorean Theorem? Learning target, we can find the sides of a right triangle. So it's all about dealing with right triangles and finding the side lengths. And there's a relationship, and that's what the Pythagorean Theorem tells us. So first things first, what is a right triangle? It is a triangle with a right angle on it. So if you look down here at the example and you look at this little symbol down here, these sides make a right angle. And if you've got a triangle, you can have a triangle with a right angle. That's where the name comes from. It's a right triangle. Now, we've got some different names for the different sides here. There's the hypotenuse, which is the longest side of the right triangle. If you look down here, it's going to be the side opposite of the right angle. Because that's the biggest angle, it's going to give you the biggest side. So if you think of that little symbol down there as like a little arrow saying, hey, the hypotenuse is over there. Hypotenuse is the longest side of the right angle. The legs are going to be the shorter sides of the right angle. So if you look, the legs are going to be the sides that create that right angle. They're also going to be the sides that create the hypotenuse there. So legs, hypotenuse, just some words that we're going to throw around here as we work our way through the lesson. The Pythagorean theorem relates the lengths of the legs to the hypotenuse, so there is that relationship that we're talking about. It's going to be a squared plus b squared equals c squared. So if you look up here, our a squared, our a is going to be a leg. Our b is also going to be a leg. So if you take the square, the sum of the square of a and b, which a squared plus b squared, it's going to give you c squared, or it's going to give you the length. You can calculate the length of that hypotenuse. So we're going to use that information, we're going to use that information and that relationship right there, that a squared plus b squared equals c squared, to answer some questions. So if we look here at the first one, what is the length of the hypotenuse of a right triangle with leg lengths of 9 and 12 centimeters? So if we go back to our a squared plus b squared equals c squared, we know that we have leg lengths of 9 and 12. So we know what this a and this b are going to be. We are looking for what c is. We are looking for the hypotenuse. So we can take those numbers and we can plug them in. So let's go ahead and plug in 9 here. I've got a 9 squared plus a 12 squared, and this is going to equal our c squared. We can crunch these numbers right here, and we know that 9 squared is 81, 12 squared is going to be 144, and that's going to equal c squared. So now we have this. We can go over here and we can say 81 plus 144 is going to give us 225. So now I have 225 equals c squared. Now, we are talking about c. We're not talking about c squared. So we need to get that c by itself. Well, what we can do is we want to undo a square, so we're going to use a square root. So what we're going to do is we're going to take the square root of both sides of the equation. What you'll see, when we've worked through radicals, if we have a c squared in here, we've got a 2 for 1, so we can take out a c, or we know that the square root undoes the square. So I've got the square root of 225. We know that this is going to end up being c, and what you can do is you can just use your calculator here, and we'll call it 225, and it's going to come out to be 15. So what we know is that c, or the hypotenuse, is going to be 15, and we're talking just centimeters. So we know that the hypotenuse is going to be 15 centimeters. So you can plug it back into the equation here, and you can see that it's going to check out. You also notice that since we're talking about the hypotenuse, this is going to be the longest side. And if you had side lengths of 9, 12, and 15, you do know that that 15 is the longest side. Let's do a couple examples over here. Let's just maybe look at one of these, and we'll look at this one right here. So now if you notice that this would be the c, we'll call this a and we'll call this b. Your hypotenuse is going to be the longest side, or it's going to also be the side directly across from that right angle. So if I've got a squared plus b squared equals c squared, I know that I have a is going to be 7, so it's going to be 7 squared plus My b in this case is going to be x, so that's going to be an x squared. Notice we're not looking for the hypotenuse because we already have it. We already know that that's going to be 25 squared. So let's just bring it down and crunch the numbers. I know 7 squared is 49. There's nothing really I can do with an x squared, so we'll just leave that as x squared. 25 squared is going to be 625. So I've got that. Now, if we work backwards, we can simplify. We can get that x by itself. So let's go ahead and subtract the 49 from both sides. The 49 gone. I now have x squared equals, I've got my 625 minus 49, 576. You've got that x squared by itself. We need to get that term by itself, and then we can take the square root of both sides just like we had before. A square root undoes a square, so I'm going to end up with x equals, I've got the square root of 576, and that's going to equal 24. So I now know that I have a side length over here of 24, and I think that's just units, so it's going to be x equals 24. That's going to be the side length over there. And what you can do is you can check it real quick by plugging it back in. I know that I have 7 squared plus my 24 squared. So 7 squared plus 24 squared is 625. Plug your 25 in here for your hypotenuse squared. And what you'll see is you also get 625. So it checks out. Last piece of the puzzle here with the Pythagorean theorem is a Pythagorean triple. It's any set of 3 positive integers that satisfy this one. Now, when you look at these, a squared plus b squared equals c squared. Remember, your hypotenuse is always going to be the biggest side. So what you're doing with these is you are plugging these in. You can call this a, you can call this b. Doesn't matter which one is which, but c needs to be the longest side. So, So what we're doing is we're checking out to see if 15 squared plus 36 squared equals 39 squared. And you can plug this in your calculator and you can see if it comes out, because 15 squared plus 36 squared is going to end up being 1521, and 39 squared is also 1521. So is this a Pythagorean triple? Yes. So if you had these side lengths of a triangle, that would be a Pythagorean triple. Over here, same story. We know that this is the longest side. We know that this is A and this is B, so we can crunch the numbers. Equals 61 squared. So you've got 12 squared plus 60 squared, and that comes out to 3744. And this should equal 61 squared if it is a Pythagorean triple, and you see it's 3721. So they're close, but they're not the same. So this right here would be a not a triple. Let's call it a PT for Pythagorean triple. So that is not a Pythagorean triple. So as you're going through and you're calculating, these examples just happen to come out, but round it to the nearest tenth if it comes out as a decimal place there. And that is the Pythagorean theorem.